Hello everyone. Today we discuss regression. First of all, what is regression? What is regression? Regression is a statistical technique. Regression is a statistical technique which is used to establish the relationship between the two or more variables. That is called the regression. Okay, it is used to establish the relationship between two or more variables. Okay, here we are taking two variables x and y. Here we are giving some values to x and y. What is the relation between these two variables x and y? How to get the relation between these two variables? Okay, for finding the relationship of these two variables, we use the regression concept. In regressions, there are so many types of regressions are there. Those are, first one is simple linear regression, multiple regression, logistic regression, Poisson regression. There are so many regression concepts are there. First of all, we discuss about the simple linear regression. In simple linear regression means it is a linear relationship between the two variables. Only two variables are involved. Okay. Those two variables are related along a straight line. That is called the regression line or simple linear regression. That means these two variables are related along a straight line relation. Or y is equal to ax plus b. Or x is equal to ay plus b. Okay, these two are the straight lines. Okay. How to get this relationship between the two variables? Okay, it is given by first simple linear regression. Simple linear regression. In simple linear regression, the two variables are related along a straight line relationship. That is linear relationship. Linear relation means the degree is 1. Okay. How to get the linear regression line? Okay, there are two regression lines. Those are regression line of y on x, regression line of y on x, and regression line of x on y. Where these two regression lines are used? Regression line of y on x. That means the regression line of y on x means the y variable depends on x. That means here x is independent and y is dependent. If y depends on x, then we form the regression line of y on x. If x is dependent on y, then we form the regression line of x on y. Regression line of x on y. There are two regression lines. How to get these two regression lines? Okay, these regression lines are directly given by the equation. First of all, we discuss about the regression line of y on x. The regression line of y on x is y minus y bar is equal to r into sigma y by sigma x into x minus x bar. Y minus y bar is equal to small r into sigma y by sigma x into x minus x bar. Here what is x bar and what is y bar and what is small r and what is sigma x and what is sigma y. Now we discuss each of these terms. Okay. Here x bar is the mean of x values, mean of x observations, and y bar is the mean of y values. For given the observations of y, we find the mean value, that is denoted by y bar. Okay. Next, small r is the coefficient of correlation. Small r is the coefficient of correlation. And sigma x is the standard deviation of x and sigma y is the standard deviation of y. Sigma x is the standard deviation of x. First we find the variance. After that we have to find the standard deviation for x values. Next, sigma y is the standard deviation of y. We have to calculate all these values, x bar, y bar, r, sigma x, sigma y. After finding these values, now next we have to substitute all these values in this regression line. Okay, here y bar r, sigma y, sigma x, x bar. We substitute all these values, we get a relation between x and y, that is a linear relationship. This is the regression line of y on x. Okay, here r into sigma y by sigma x. This is called the regression coefficient. This is called regression, slope of the regression line. This is called the regression coefficient. Regression coefficient. Regression coefficient of y on x. Regression coefficient of y on x. The slope of this regression line is r into sigma y by sigma x. Particularly, this slope is known as regression coefficient of y on x, and it is denoted by small b suffix yx, byx. Okay. So this is about the regression line of y on x. Similarly, regression line of x on y. Okay, just to replace x and y in this relation, we get a regression line of x on y. Okay, now we discuss here. Regression line of x on y is, here x is dependent on y, then we form the regression line. The regression line of x on y is x minus x bar is equal to r into sigma x by sigma y into y minus y bar. This is the regression line of x on y. Here x bar, y bar are the means of x and y, mean of x and mean of y, and small r is the coefficient of correlation, and sigma x, sigma y are the standard deviations of x and y. Here for this regression line, the slope of this regression line is r into sigma x by sigma y. This r into sigma x by sigma y is called the regression coefficient of x on y. This is the regression coefficient of x on y, and it is denoted by bxy. Regression coefficient of x on y is bxy. It is denoted by bxy. This is about the regression line of x and y. Okay. So these are the simple linear regression lines. That means the linear relationship between the two variables which are related along the straight line relation. Those lines are called regression lines. There are two regression lines, that is the regression line of y on x and the regression line of x on y. Okay. On this each and every term we have to calculate x bar, y bar, r, sigma x, sigma y. We have to substitute all these values, we get the regression lines. This is about the regression lines concept. Okay, based on the regression coefficients, we have to find the coefficient of correlation. If suppose two regression lines are given, so from that we have to find the slopes of the regression lines bxy and byx. So based on the regression lines, we have to find the coefficient of correlation. If suppose y is equal to byx into, this is the slope, into x plus c1, and x is equal to bxy into y plus c2. Okay, this is the regression line of y on x, and this is the regression line of x on y. Here the slopes are byx and bxy. If the two regression lines are given, y on x and x on y regression lines are given, based on these two regression lines, we have to find the coefficient of correlation. Okay, how to calculate the coefficient of correlation? So from these two equations, we have to find the slopes of these equations, byx, bxy. Okay, byx into bxy. First we have to find out byx into bxy. What is the formula for byx? This is the slope of regression line of y on x, that is r into sigma y by sigma x, into bxy is r into sigma x by sigma y. Here sigma x get cancelled, sigma y get cancelled. R into r, r square. Here r is the coefficient of correlation. R square is equal to byx into bxy. So from this r is equal to square root of byx into bxy. Okay. So by using this formula, we have to calculate the coefficient of correlation small r based on the regression coefficients. If the two regression lines are given, so from those two regression lines, first we have to find the slopes, that means the regression coefficients byx and bxy. Okay. By using these two slopes, we have to find the coefficient of correlation smaller by using this formula, square root of byx into bxy. Okay. This is about the regression lines concept. Okay. And another one is we have to find the mean values of x and y from these two regression lines. If the regression lines are given, if the regression line of y on x and the regression line of x on y are given, from these two equations, how to find the mean values of x and y? Clearly, the regression lines are passing through the point x bar and y bar. The regression line of y on x and the regression line of x on y both are passing through the point x bar and y bar. That means this point satisfies both the regression lines. Now substitute this point in these two regression lines. So y bar is equal to byx into x bar plus c1 and x bar is equal to bxy into y bar plus c2. Substitute this x bar y bar, that means since this point satisfies these two regression lines, now we have to substitute this point in these two regression lines. We get two equations in terms of x bar and y bar. Now we solve these two equations for finding x bar and y bar. X bar and y bar are the mean values of x and y. By solving these two equations, we get mean of x and mean of y. Okay. For finding the mean values of x and y based on the regression lines, just we have to substitute this x bar y bar point in the regression lines. That means this point satisfies these two regression lines, and after substituting x equal to x bar, y equal to y bar in the regression lines, we get two equations in terms of x bar and y bar. Now we solve these two equations, we get the means of x and mean of y. We get x bar and y bar values. Okay, this is about simple linear regression. Simple linear regression, there are two regression lines, regression line of y on x and regression line of x on y. Okay. Based on the regression lines, we have to find the coefficient of correlation also. If the regression lines are given, then how to find the coefficient of correlation? That is given by small r is equal to root of byx into bxy. Byx, bxy are the regression coefficients. Those are the slopes of the regression lines. Okay. After that, by using the regression lines, we have to find the mean values of x and y also. This is about simple linear regression. In the next video, we have discussed multiple linear regression. Okay, multiple linear regression means that is relationship between three or more variables, more than two variables. More than two variables are connected by a linear relationship, that is called the multiple linear regression. In the next video, we have to discuss that concept. Okay, thank you.